Okay, so we are in the topic of nonlinear inequalities, and we'd already done one example using the sign chart method. Now, again, I'm doing it using the sign chart method because it's the most, I would say, systematic step-by-step method that you can use to solve these inequalities. I strongly urge you to use the method and follow the steps. How many steps did we define? I believe 4 steps that we defined to solve the inequality. If you follow those 4 steps, you're going to get to the correctly. You're going to get to the correct solution. So let's eliminate the risk and the inference that we might do that might take us to create or to generate a mistake. Okay. So now we're going to solve this one here. I'm going to be going through the steps as we had seen them in the previous example. I'm going to be going a little bit more quicker because now we know, now we've seen already one example. Okay, so the cursor here. Here. There we go. Okay, so remember that, whoops. Turn on the camera by accident. Okay, there we go. Okay, so remember that we had some steps that we had followed. So actually, step 0 is already here. And remember that that first step, or step 0, was when we left the inequality with a mathematical expression to the left and 0 to the right. Okay, so that would be step 0. Okay, now step 1 was to factor and identify the roots. Okay, and so how do we identify the roots? Well, first we factor the expression. In this case, the expression is already factored. Be very careful with these problems. If the expression is already factored, then we can already find the roots, or that step has already partially been made for us. Leo, in the example that you sent me yesterday in your procedure, you had an expression like this that had already been factored. And what you did was multiply the factors. We shouldn't do that. If it's already factored, we can find the roots directly there. And so what would be the roots in this case? Well, we've got 2 factors, which is x plus 4. And so the root here in this case is going to be x equals minus 4. And then we've got another factor here, and this root is going to be x equals minus 8. Okay, I'm going to be going through the procedure. If anybody has any questions, remember to let me know, or just raise your hand or open your mic and jump in. And so now we've got the 2 roots of the system. It doesn't really matter that it's elevated to the 2 or elevated to the 3. It's still the root. It's the value that's going to make that element 0. What was step 3? Step 3 was identifying. I'm sorry. Step 2. Step 2 was identifying Step 2 was going to be to identify the intervals that we're going to be using. Okay, and so the intervals are going to be defined based on the 2 values, or the whatever amount of values we have as roots. So just remembering what we had talked about, if we have the number line, and the number line has the 0 as a reference, The -4 is going to be around here. The -8 is going to be around here. Here we've got positive infinite. And on this side, we've got negative infinite. Okay. And so what are going to be the ranges or the sections that we're going to be having in for these intervals? Well, it's going to be, we're going to go from left to right. So it's going to be minus infinite, comma, the first number we encounter is -8. Then we're going to incorporate the 8. Then, I'm sorry, the -8. Then it's going to be from -8 to -4. Then the -4. And then we're going to go from -4 to infinite. Okay? And that's going to be step 2, establishing the intervals. Okay? Remember, all of this is going to be in the updated PowerPoint that I'm going to upload later today. All of the notes, okay? Questions with this one before I jump to the next slide and the next steps? No?
No.
Okay. I am going to share with you guys in the chat this screenshot. So you guys can have it there, okay? Okay, we're going to jump over to the next slide and continue the steps, okay? And so let me clear this slide. We're going to jump to the next one. Now, step number 3 is going to be to fill in the sign chart. Okay, so this would be step 3. Okay, and how are we going to fill in the sign chart? Well, on the top, the columns are going to be the ranges that we had defined. So it's going to be from minus, let me make the width of that line a little bit bigger. Sure. So taking the intervals we had, it's going to be from minus infinite to -8, -8, from -8 to -4, -4, and from -4 to infinite. Okay, those are going to be the ranges. And in the rows, we're going to write down the factors. So one factor is going to be x plus 4 to the square. The other factor is going to be x plus 8 to the 3. And here we're going to have the combination of the two factors, which is the end result that we're going to be evaluating. Okay, that's step number 3. We're still in step number 3. Now what we're going to do is fill in the sign chart. I'm gonna call on somebody so they can help me out. Let's see, Jesus Aceves. Hello, sir. Are you there?
Yes.
Perfect. Thank you, Jesus. Now help me out with the first row. Remember that what we're doing, Jesus, is we're trying to identify if this factor here relating to each of these ranges? We're just trying to know, or we're just trying to identify if it's positive or negative. So what can you tell me here? Let's look at the first one. From minus infinite to minus 8, if I select any number in that range, what am I going to get if I substitute in the x plus 4? Positive or negative?
Positive, because you get a negative number, but since it's squared, it's always positive.
Perfect observation. Great, Jesus. We don't need to do a very strict analysis for that whole row. I hope everybody else saw what Jesus saw. This is elevated to the square. And the takeaway here, Jesus and the rest of the group, any value that is elevated to an even power is always going to be positive. So if that's a 2, that's a 4, that's any even power, the result is going to be positive. So good observation, Jesus. Would you agree that I can put a positive on all of this, on this complete row?
Yes.
Perfect. Thank you, Jesus. Perfect. Anything that's elevated to a, well, I made a mistake in one of those. We need to see. What happens if, Jesus, I'm still with, what happens if I substitute the minus 4?
0 and 0, yes.
0, correct. Remember that 0 is neutral. Okay, so it's neither positive nor negative, and this is positive. Thank you, Jesus. Good. Anything that's elevated to an even, anything that's elevated to an even power is going to be positive. Now let's see. Anna, are you there?
Yes.
Hi, Anna. Help me out with the second row. If I substitute any number between minus infinite and minus 8. In the second factor, what am I going to get? Choose any number you want, and let's see what we get there.
Well, negative. Wait. Is it from negative infinite to negative 8?
Yes.
Okay. So negative 9.
Negative 9. If I substitute negative 9 plus 8 is going to be how much?
It's going to be negative 1.
Perfect. Negative 1 elevated to the 3. What am I going to get?
And negative 1.
Negative.
Yes.
If I substitute anything in that range, it's going to be negative.
Yes.
By the way, if I have an even power, I'm sorry, if I have an odd power like 3, I'm going to get the whatever sign I have. So if it's negative, I'm going to have negative. If it's positive, I'm going to get positive. So the power isn't going to really affect that. If I substitute the minus 8, Anna, what am I going to get?
You're going to get 0.
0. Perfect. If I substitute anything between minus 8 and minus 4, what am I going to get?
Negative.
Negative? Let's choose a number there, Anna. Choose any number between minus 8 and minus 4.
Minus 5.
Minus 5. Minus 5 plus 8 is equal to?
3.
3 positive, elevated to the 3, it's going to be positive. So this one's going to be positive. If I substitute the minus 4, what am I going to get?
Positive.
Positive. And if I substitute from minus 4 to infinite, what am I going to get?
Positive.
Yep. The easiest number to choose there is 0. 0 plus 8 is plus 8 elevated to the 3. It's still going to be positive. Notice something here. The 0 is a turning point. Usually the 0, for some cases, at least for the odd, is going to change. It's going to have negative, 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 0, then positive, or positive, positive, 0, negative. It's going to make that change. Thank you. Thank you very much, Anna. Let's see. Let's see. Alfredo. Hello, sir. You there?
Yes.
Okay, perfect. Now help me out with the rest of the sign chart. What we're doing here is now, if I multiply these two, according to what I have, what sign am I going to get? So for the first column, plus times minus, what am I going to get here?
Plus minus.
Plus multiplied by minus, what am I going to get? What sign?
Well, negative.
Are you sure?
Well, no.
Why not? If I multiply a positive number times a negative number, Alfredo, what am I gonna get?
Well, it's negative.
Okay, so are you sure?
Yes.
Okay, perfect. That's what I want to hear. Let's remove the interrogation sign at the end of the question mark at the end of our answer. Yes, it's negative. If I multiply something positive times 0, what am I going to get, Alfredo?
Well, positive.
No, if I multiply something positive times, if I multiply anything by 0, what am I going to get?
Ah, 0, 0, sorry.
0. Remember that 0 is Switzerland, 0 is neutral. Positive times positive, what am I going to get?
Positive.
Perfect. 0 times positive, what am I going to get?
0.
And positive times positive, what am I going to get?
Positive.
Perfect. Thank you, Alfredo. Perfect. Now we filled in the sign chart. Now we're going to go with step number 4, which is evaluating the sign chart. Okay. Step 4 is evaluating the sign chart with regards to the inequality. Okay, so let's see, Fernanda, help me out here. So in the original inequality, what does the original inequality say?
That it has to be bigger than 0.
Correct. Perfect. And you said it perfectly. It has to be bigger or larger. Larger than 0, not larger or equal. It says larger. So we're not including the 0. So let's go through this, Fernanda, help me out. For the first interval, which is this one here, does the first interval comply with the inequality?
No, because it's negative.
Correct. So this first interval does not comply because it's negative. Does the -8 by itself comply with the inequality?
No, because it's 0.
Correct, because the inequality is not considering the 0. You're doing wonderful, Fernanda. The next interval from -8 to -4, does that one comply with the inequality?
Yes, because it's positive and positive is bigger than 0.
Perfect. Just that when you said yes, there was a question mark at the end. Let's remove the question mark. So you said yes. So let's say yes. Okay. Perfect. Does the -4, is the -4 a part of the inequality?
No, because it's 0.
No, because it's 0. That is correct. Let me change colors here. Because it's 0. And lastly, in the last interval, which is -4 to infinite, does that one comply with the inequality?
Yes.
Because it's positive. Perfect. Thank you, Fernanda. Well done. And so the solution that we're going to have for this problem is going to be the intervals that go from -8 to -4 and from -4 to infinite. This would be our solution. Okay. What this means is if I take any number within those intervals, it should comply with the original inequality. Okay. Questions with this one? I'm going to take a screenshot and I'm going to send it to you guys as well. And remember, all of this is going to be in the next PowerPoint. Okay. Questions with this one? No?
Teacher,
Yes, go ahead.
so in an exercise, if we see the exponents and it's already like this, already factor, we don't pay attention to them.
No, because we're interested in the factors. So if it's already factored, what we need are the roots. And if it's already factored, then we can get the roots directly from the factors. Okay, so a pitfall here for this exercise would have been to say, okay, I'm going to multiply everything and get a huge polynomial and see how I can simplify that. That would be that would be unnecessary. Right now, the polynomial is already factored, and since it's factored, we can already take the roots. Now, the roots are still going to be -4 and -8, regardless of the exponents. So if the exponents are whatever number, the roots are still going to be those numbers that are going to make the inside of the parentheses, that mathematical expression, each of those are going to be the values that make them 0. So regardless of if it's elevated to the 2, 3, 5, 7, whatever, in x plus 4, -4 is going to make it 0. In x plus 8, -8 is going to make it 0. So those are the values we're looking for, the roots. So it really doesn't matter the power it's elevated to. Did
Okay.
that answer the question, Juan?
Yes, teacher. Thank you.
Perfect. Okay. Aimee, please go ahead.
When do we have to use brackets instead of parentheses?
Perfect. Very good question, Aimee. Okay, so I'm gonna doodle some things here in this example, just to demonstrate and answer Aimee's question. So Aimee, let's imagine that instead of this being greater than, it's greater than or equal. Okay? It's greater than or equal. If that would have been the case, then the -8 and the -4 would have been included. Why? Because it includes the values that make the inequality 0. If that would have been the case, then those values that are included in the extremes, we put them in brackets instead of parentheses. So if this would have been the case, then we would have said, and actually, since it's including the 4, we could have just said that this is from -8 to infinite. When we're including the number, within the range that we're analyzing, that's when we use the brackets. When we use the parentheses, that means that that number isn't included as a part of the solution. Let me correct that right here. It means that that number is not included as a part of the solution when we use the parentheses. When we use the brackets, that number is included. Was that clear, Aimee?
Yes, thank you.
Perfect. Thank you for the question. That was a good question because we need to be able to differentiate those situations. Okay, good. Let's jump over to a next exercise. I'm going to clear this. I already sent you the screenshot. I'm going to clear this. And let's do another one. I'm going to give you a few minutes to think about this one. I'm going to give you a few minutes to think about this one. And then we're going to solve it here. A few minutes to think about that one. When I ask you guys to think about it, try to do it in your notebooks or your pages or wherever you're writing. And I'm going to give you a few minutes and I'm going to hum. I'm going to hum a song. And if anybody recognizes the song, please say so. Daniel, go ahead.
Is it the one of Jeopardy?
Oh, yeah, it's the Jeopardy song. Well done, well done. And I'm gonna give you guys a hint here. And just remember the steps. I'm giving you the steps so you can follow a certain order. And remember that there was a step 0. For that step 0, I have to have something less than or equal to 0. I have to turn this into something that looks like this before I begin. Before I do anything else, I need to do that. And we're gonna have to do refresh our algebra there to do that.
Teacher, can you confirm if my equation is correct? Like the step 0.
Can you share?
I'm doing it on my notebook.
Can you send me a picture via?
Sure, on WhatsApp.
Yeah, on WhatsApp.
All right.
We're gonna solve it here. Don't worry about that. But I can check it. I can surely check it. Okay, we're going to take a 10-minute break, and we're going to come back to work on this. And send me a screenshot, Miguel, and I'll check it. So 10-minute break, and we'll be back. I'm going to pause the recording. The first thing we need to do is which is step 0, is that we need to represent the inequality as something, a mathematical expression on the left, the inequality symbol, and a 0 on the right. And so we're gonna have to do some algebra here. Now, let me comment on, and I'm gonna write that down in red. This is something we cannot do. I'm gonna write it down here in red, and then I'm gonna erase it. So this is the inequality. This procedure that I'm going to do right now is a procedure that is incorrect, and I'm going to explain why in a moment. We can't do that. We cannot do that. Now, if we were talking about an equation, we could do that. We could just multiply by the corresponding factor on each side, which is the x plus 2 that I want to eliminate, and just leave it like that and start working. This is incorrect for an inequality. Now, let me explain why. Okay, so Miguel, a question. Are you there, Miguel? So, Miguel?
Yeah, I'm here.
Oh, there, hi, Miguel. Okay, A question for you, Miguel.
Yeah.
Do you know the value of X?
No,
No, right? Do you know if X is positive or negative?
huh?
Do you
Yes.
know if X is positive or negative?
No, I don't think so.
You can, the X is a variable, right? It can take on any possible value depending on the restrictions. You don't know, and therefore you don't know if this factor that you're multiplying by, you don't know the sign of this factor, right? You don't know the sign of this factor because X is a variable, okay? And so remember all of you guys, remember the rules of the theorems for inequalities. If I have something that's adding or subtracting, I can add or subtract things on either side of the inequality without the inequality being affected. However, I cannot multiply, if I multiply by things on each side of the inequality is going to change depending on the sign. Therefore, I cannot multiply by a factor where I cannot assure with 100% accuracy what sign that factor is going to have. And so again, if this were an inequality, Miguel, your procedure would be, if this were an equation, Miguel, so instead of having if this were an equation, then the procedure you sent me would have been perfect. You just multiply algebraically. But we can't do that in an inequality because of the theorems. So we have to work around that.
So we just can subtract and add,
Yes.
but not multiply or divide, or
We can multiply or divide as long as we know what sign it is that we're multiplying or dividing. So for example, if you were just to multiply by an, I don't know, -2, that's fine because I know -2 is
oh,
minus.
so if it doesn't have X on it, you can.
Yes, correct. If it doesn't have an X, if it doesn't have a variable in it, we can multiply or divide. We just have to be mindful of the sign because of the sign it's going to flip, depending on if it's positive or negative. But if there's a variable there, we can't know the sign, so we can't just multiply or divide by things because we don't know how the sign is going to be affected. So we're going to have to do some algebra here, and I'm going to go through it here, and you can check it out how you have it in how all of you have it in your notes. Let me just erase this one here. So in the end, what I want is that I want everything to be on the, I want a 0 on the right-hand side. So what I'm going to do is the following for step 0. Okay. Step 0. I'm going to do the procedure here. And I'm going to go through it. And if you have any questions at any moment, please let me know. So we've got X less than or equal to 3 minus 6 divided by X plus 2. So what I'm going to do is that I'm going to send everything that's on the right, I'm going to send it to the left. And what's going to happen is that I'm going to have this. I'm going to have X minus 3 plus 6 divided by X plus 2 less than or equal to 0. So the only thing I did there is the 3 is positive. I'm sending it to the other side negative. The 6 divided by X plus 2 is one factor. It's one element. I am going to send it to the other side with a different sign. And that I can do without affecting the inequality. Jesus, please go ahead.
Will the answer change if I did the opposite? I just subtracted X to the other side.
That's a good observation. No, as long as you were careful about the inequality where it's facing. So
Yes.
what Jesus is saying, I'm going to write it on the other side. Another alternative would have been to do this. 0 is less than or equal to 3 minus 6 divided by X plus 2 minus x. This is what you did, Jesus?
Yes.
That's correct as well. And you can follow the same procedure, the same step procedure. You can do it with either one. You should get to the same result as long as you're mindful of the way the inequality is facing. Okay? But yes, that would also be another alternative, and it is correct. Okay? Now, I'm not done yet here because I need the roots. And the way this expression is written like that doesn't really help me to find any roots. So the next thing I'm going to do is that I'm going to try to make this into one into one block or one factor. And so what I'm going to do here is that I'm going to take a common denominator, which is x plus 2. I'm going to take a common denominator, which is x plus 2. And then I'm going to have x minus 3 multiplied by x plus 2 plus 6. This is less than or equal to 0. The only thing I did there is to grab a common denominator and join join everything into one fraction. Okay.
Teacher,
Yes, Joel, go ahead.
and if I do that, but in the first step, yeah, I solve the 3 minus 6
You
by
join-
x plus 2.
Yes, you
And
join
then-
those two, and then you send them to the other side. That's perfect. And then you join them with the x.
Okay,
You should get to the same thing I'm getting to. That would be correct as well. What Joel is saying is that he first did the common denominator with these two, then he sent them to the other side, and then he joined them with the x. That procedure that would be correct as well, and you should get to the same thing I'm going to get at. That's correct. What I'm going to do now is I'm going to multiply these. So this is going to be x squared minus 3x plus 2x is x, minus 3 times 2 is minus 6, plus 6, divided by x plus 2, less than or equal to 0. And what's happening here is that these two x's are going to cancel themselves out. And what I'm going to have is x squared minus x divided by x plus 2 less than or equal to 0. Now, I want things to be completely factored, so I'm going to bring this over here. And what I want is I'm going to factor the x here, and it's going to be x multiplying x minus 1 divided by x plus 2. And this is less than or equal to 0. This would be all of this procedure that we did here. This would be step 0. Okay, this would be getting to here. This would be step 0. Okay, we have the expression and we have a 0 on the right. Now, this is the first example we're seeing with a quotient. A quotient is where we have a numerator and a denominator. Now, in the end, what we want is we need the factors. We need the numerator to be completely factored and the denominator to completely
Sure.
be factored. Yes, go ahead.
I don't know if you already said it, but like, can you repeat how did you know what the roots was, or what was your?
Luis Gallardo, right?
Yes.
No, that's the next step. We haven't gotten to the roots.
Okay, thank you.
Okay, so the next step actually is, I'm sorry, actually, let me correct something here. This is step 0, And the factorization that we've done here would be step one, and we need to identify the roots, like Luis Gallardo mentioned. That would be our next step. Okay, let me make this window a little bit shorter so I can see what I'm writing. Okay. Now we're going to go to step one, which is identifying the roots. And so for step one, we're going to be looking at the expression that we just found, okay, which is this one. And we're going to be identifying the roots. And again, remember, the roots are going to be, after we factor, are going to be the values that make the factor 0, or if we have a quotient, they're going to be the ones that make the denominator 0, or the factors of the denominator 0. So in this case, the factors are going to be, or the roots are going to be x equals 0 for the first one, x equals 1 for the second one, which are these two, and x equals -2. These are going to be the three, the first two values make the numerator 0, the last value makes the denominator 0. Those are going to be the values that we're going to take into account. And step 2 is, yes, Jesus, please go ahead.
I don't know if I did something wrong. Doing the subtraction, but in the numerator, when I factorize it, I have x times minus x plus 1. I have like the signs are switched. I don't know why.
Could you say that last part again?
That I did everything like you did, but in my numerator I have x and then in parentheses minus x plus 1.
It's the same thing. In the end, what are the values that make those two factors 0? Jesus.
I
X equals
see.
0,
Yeah.
and it's x equals, again, basically what you're doing, Jesus, by putting it to the other side, you're doing exactly the same thing I'm doing, but everything is multiplied by -1.
-1. Yeah, I see.
But the important thing here, Jesus, is that the roots, your roots, even though your expression is a little bit different, your roots are exactly the same. Would you agree?
Yes, they are.
You have the 0, the 1, and the -2. Okay, and the important thing is to identify the roots. Okay, was that clear, Jesus?
Yes, thank you.
Okay, perfect. And so now step 2 is to identify the ranges. And so we've got the 0, we've got the 1, and we've got the -2. And so if we identify the ranges here for this inequality, we're going to have from -∞
It's the
to -2. Be careful about the open microphones, okay? Because it's being recorded. Then we've got -2. We've got from -2 to 0. We've got the 0. We've got from 0 to 1. The 1, and we've got from 1 to infinite. These would be the ranges. I started writing very large, and then I ended up writing very small there. Take a screenshot of this. I'm taking a screenshot of this, and I'm sending it to you guys in the chat. Again, all of this procedure is going to be in the updated PowerPoint. Questions up to this point? This is the trickiest part. The other is just filling in the sign chart. Questions with this one? with what we did up to this point before we, before we,
Yes, teacher.
yes, go ahead, Luis.
And the step 0. In the second part, how did you know it was going to be x minus 3 times x plus 2?
Oh, okay, give me a moment.
Like, what was your steps to which?
Okay, so what we do here, Luis, is that with this part of the expression, use another color just to differentiate. With this, when we've got the expression up to here, Luis,
Yes.
what we're doing is that we're grabbing a common denominator. Basically, Luis, what we're trying to do, Luis, is that we've got many elements there.
Okay, I got it.
We're trying to bunch them into just one quotient. Okay?
Yes.
Yep, so we're grabbing the common denominator over here. And then we're saying this times this
Yes.
is this part here. Okay, so whenever we have it that way, and we have a fraction, we're going to try to bunch them together to get one fraction out
So
of it.
it's the common denominator step.
Yep.
Okay, I get it. Thank you.
Okay, good. Thank you. I'm going to jump over then to the next part of the procedure. Okay, and I sent you this screenshot. And so now we're gonna fill in the chart here very quickly, and we're done. So we're going from minus infinite to -2. We've got the -2. We've got -2 to 0. I think I'm missing some. Yeah, I think I'm missing some columns in this one. Give me 1 second here, just add some columns here because I copy pasted another table to this one. Just give me one moment here. Just one. Okay, there we go. That's better. I was missing some. I copy pasted the other table and I was missing some columns there. So we're gonna get from minus infinite to -2. I hope I didn't miss any columns. From -2, and we're gonna have -2 to 0, 0, 0 to 1, 1. And 1 to infinite. Okay. And over here in the rows, we're going to have the different factors, which would be x, x plus, sorry, x minus 1. Then we've got x plus 2. And then we have the whole expression, which is x times x minus 1 divided by x plus 2. Okay. And I'm going to fill in the sign chart here, and let me know if you have any questions. So here for and verify with your filling in of the sign chart. Here I've got an x. So basically for the x, anything that's positive is going to be positive. Anything that's negative is going to be negative. So in this range here, this is going to be negative, negative, negative. I'm going to get a 0 here, and then it's going to be positive, positive, positive. X minus 1. If I substitute the 1, it's going to be 0. If I have anything that's larger than 1, from 1 to infinite, it's going to be positive. If I have anything that's less than 1, it's going to be negative. So the 0 can be a reference there. Notice I'm filling this one out a little bit quicker. The -2 is going to be the reference for this factor. And so if I have anything that's larger than the -2, it's going to be positive for any value here. If I have anything that's less than the -2, it's going to be negative. Okay. And that, in the previous one, we just multiplied by 2 values, plus times plus, plus times minus, etc. Now we've got 3 values. The same rules still apply. So minus times minus is positive. Divided by minus is negative. Minus times minus is positive. Times 0 is 0. Minus times minus is positive. Divided by positive, positive. 0 times whatever is going to be 0. Plus times minus is minus. Times plus is minus. 0 times anything is 0. And we've got plus, plus, plus here. This is going to be plus. That's the product that we have there. The next thing that we're going to do is that we're going to, oh, I forgot to write down that this is, remember that this is step
3.
3, perfect, correct. And now we're going to be doing step 4 here, which is evaluating. And for the evaluation, we're going to look at this expression here. I'm going to write it down here on top, just to remember that we're using an expression that is the corrected expression. So what we're evaluating is x multiplying x minus 1 divided by x plus 2. And this is less than or equal than 0. So this expression is equivalent to this expression here. All of this expression is equivalent to this expression here. Okay. And so if it's less than or equal than 0, we're looking at intervals that give us a negative value or a 0. So let's start evaluating the sign chart. So for the first column, this is negative, this is part of the interval. Since it's less than or equal, then this is a 0, this is also part of the interval. I'm just going to look at the negative ones. This is also part of the interval. The 0 is part of the interval. The 0 is part of the interval. And anything that's positive would be left out. This means that the solution for this inequality would be, I'm going to write it down here instead of in the bottom. The solution would be from minus infinite to -2. And going back to Aime's question, we're including the -2. And so if we're including the -2, this has a bracket. Union with 0 to 1, but we're including the 0, and we are, oh, wait a minute. This is being recorded. I mean, I actually I actually made a mistake here. Let me correct this. Let me quickly correct this. This number here, the -2, cannot be included. Can somebody tell me why it cannot be included?
Because it would be divided by 0.
Correct. So here's a little caveat for these inequalities that have quotients. We're not going to include the values that make the denominator 0. Those are automatically going to be eliminated because we can't have a denominator being 0, because that generates an infinite value. And besides, a denominator 0 that makes the whole quotient be infinite, positive infinite or negative infinite, in the end does not comply with any inequality that's larger than or less than. So we eliminate those. And so going back to the solution, and remember that this is being recorded, so you can go back and review this. Going back to the solution, we're going to go with minus infinite to -2. We're not including the -2 because it makes the denominator 0. And then we're going to go from 0 included, because that is part of the solution, to 1. And the 1 is also included, and that's why we're using the brackets. And so this would be the final solution. It actually can fit here on the bottom. Just to keep the nomenclature of what we've been doing before. This would be the solution, following the sign chart. Take a screenshot here and send this to you in the chat. Questions? Questions with this example? Okay. Good. Now any questions before we close up this part? Any questions? No. Okay.